Okay, so this problem will be an application of a rule called voltage divider rule, which is basically uh, just manipulation of Ohm's law. So it goes like this: when a voltage is distributed among several resistances, several elements, then the rule says the rule gives an expression that lets us find the voltage drop across any of those elements basically. So I have just given three resistances here. This is a voltage here, Vs, R1, R2, R3. So we can see that this is a series arrangement between series arrangement of three resistances and a voltage source. So let's say we want to find voltage drop across across R3, which is V3. So we can see that there will be one current since it's a series circuit. So Vs will be essentially I times R1 plus R2 plus R3. So V3 will be, of course, I times R3. We know that from Ohm's law, and this is also from Ohm's law. Now I can be substituted from here, uh, Vs divided by R1 plus R2 plus R3, which is basically I, times R3. This is the voltage divider rule basically. If it were V2, which would be a voltage across R2, that would be this thing multiplied by R2. And if it were the R1, the voltage drop, then V1 would be this thing multiplied by R1 basically. So that's the rule. We directly apply from just manipulation of Ohm's law. So there it is. Now we want to find the voltage drop V0 across this resistance 75 ohms when RL is infinity and when RL is 150 kilo ohms. So when RL is infinity, that means this is an open circuit. We don't have anything connected here. We can just ignore this one. So then when we apply voltage divider rule, that will be V0 will be total voltage 200 divided by sum of these two voltages 75 25 plus 75 times 75, and that gives us 200 divided by 100 times 75, so that's 150 kilo ohms. That gives us the voltage drop across 75 ohms kilo ohms. So that's fine. But when RL is become 150 ohms, not infinity anymore, then there is a finite resistance here, and then we cannot directly apply voltage divider rule. First we have to find the equivalent resistance. So if equivalent resistance of these two resistances, because these two are in parallel. Recall that voltage divider rule is always like this, few series elements, because then only we have one current. Here we have this current is not this current basically. This current is split into these two currents. So we have to find the equivalent resistance of these two, 75 ohms kilo ohms and 150 kilo ohms. That will be 75 times 150 divided by 75 plus 150, parallel of equivalent of two parallel resistances. That will be then 75 times 150 divided by 225, so that's 9 here, and then 3 here, and then we have 3 here, and then we have, if we divide by 50 by 3, so that becomes 50, so then 3 getting cancelled, so that's 50 kilo ohms. So that's the new resistance now. So we can redraw the circuit. We can simplify because all we have to find is V0. So this is not changing because these two are in parallel. So even if we replace them by one resistance, the V0 remains the same. So this is, we couldn't have done it if we had to find current through this branch, of course, because then we had to, we can do that like that. But in this case we have to find the parallel the voltage across these two elements, which is the same basically. So 25 kilo ohms now and 50 kilo ohms, and this is 200 volts as before. So now V naught, which is a changed one, will be 200 divided by 25 plus 50 times 50 now. So I don't know, it's a bracket parenthesis. So this is becoming, once we do it, this is 75 and 50, and once we do it we get 133.33 volts. So we can see the voltage is less now because the resistance is also less. So whenever we connect a parallel resistance, the equivalent value of course decreases and it becomes less than the lower value of the two, and if it is more than, then also lower value than the lowest one basically, and the voltage drop is also less as a result. So yeah, that's what I wanted to show. This is just an application of voltage divider rule.